Okay, so our next talk is on OmniPath and OpenFabric's interfaces, and it will be delivered by Brian Smith. Brian is the Director of Technology at Cornelius Network. Brian has more than 25 years of experience in HPC, starting as an undergrad researcher as a system admin at the US DOE Ames lab facilities. He received 2 bachelor degrees in computer engineering and electrical engineering with 2 minors and a master's degree in computer engineering from Iowa State. He moved from there to IBM, where he led the communications team for BlueGene L, P, and Q. He has over 100 patents and was an IBM master inventor. Brian went from IBM to Oak Ridge National Labs, where he worked on several projects in parallelizing data analysis for climate science codes. He also worked in user support for the Oak Ridge Leadership Computing Facility, Node AA, and Air Force Weather. And I was excited to read that in his spare time, Brian is very active in FIRST FRC Robotics, where he mentors high school teams. And thank you for your service, actually.
Thank you. Yeah, so my name is Brian Smith. I'm the Director of Technology at Cornelius. That one, okay. Standard notices and disclaimers, everybody read that, sign the EULA. Okay, agenda, just gonna, kind of a brief introduction of Cornelius. Tim Thompson sort of did that yesterday, but I'll do a little bit as well, just in case anyone wasn't here. And then discuss the OpenFabrics Alliance and LibFabric specifically, some of the history there, go over the LibFabric architecture a little bit, and then a little bit of a comparison to Verbs and UCCX. We've had a lot of discussions on UCCX here, so I just wanted to sort of provide some opinion on the philosophical differences there. And then I'll discuss OmniPath and OpenFabrics and how we're actually using OpenFabrics. And then one brief slide on our future and what we're doing next. So who we are, our current CEO, Phil Murphy, founded a company called Silverstorm in 2000. This was an IB company. It got bought by QLogic along with PathScale. And then Intel bought QLogic, and at the same time, well, about the same time, Intel also bought the IP from Cray for the Aries, Gemini, the C-Star, basically the network technology they had at the time. They sort of combined the best of IB and the best of the C-Star interconnects, and that was OmniPath. We split out of Intel about 3 years ago. At a break, I can tell you sort of the history there if you want, but I didn't feel like we should do that right here. So we have a lot of history here with IB starting, back in the Silverstorm days and then through OmniPath. And because I work with the marketing guys, I have to at least throw this slide up here. So we are a full end-to-end solution. We sell adapters, edge switches, director class switches. We qualify cables. We have InfiniBand and Ethernet gateways as well. So that's done. Good. Okay, so what is OpenFabrics Alliance? This was started in 2004, and the goal was really to advance the development of open source software for networking, right? So they currently support and maintain existing fabric technologies, right? So this is the OFA group as well. But they also are working on developing new and emerging technologies and applications as well. They work very closely with other open source communities to ensure adoption as well, right? So we work with the Linux kernel guys, the Linux kernel community to ensure that LibFabrics has support there. We work with the storage vendors, that's the SNIA group, and then DMTF is the fabric management groups as well. So we want to make sure that all of the LibFabric work and all the OFA work in general is accepted by the community. There's a large body of promoters, adapters, and supporters. Most of the national labs, most of your standard networking companies, at least have some interest in OFA. And then most of the Linux providers as well, or Linux distributions as well. So OFA consists of multiple working groups. The one I'm going to talk about the most is the OFE WIG, the OpenFabrics Interfaces Working Group. But there's a full marketing working group, there's a fabric management group, and then there's a software development working group, which is the ones that work with the community to make sure that OFI is accepted. There's an annual workshop as well, and I think it was actually here in Columbus last year. I didn't make it, but I think it was in Columbus. It's normally in April. And then OFA has a really strong industry alliance program, right? I mean, that's part of why Cornelis is active there. So the OFI WIG, this is the LibFabric group essentially. So the OFI WIG charter is to develop an extensible open source framework and interfaces aligned with upper level protocols and application needs for high performance fabric services. It's a lot of words, but it's essentially just saying that, you know, the goal here is to maximize the impedance match between upper level protocols such as MPI, SHMEM, et cetera, and the network APIs. So what does your hardware look like? You know, make sure that that hardware and the software at the next level match very well. Part of the original early design here, they actually did a lot of analysis on MPI and SHMEM and other programming paradigms to make sure that the APIs are well matched, right? So that they did make sense between the OFI LibFabric and the network and service providers that were out there at the time. Since then, they've also done some work with storage, so like the Deos Mercury interfaces, for example. AI, ML, DL, of course. There's some database work. If you do any of the Intel 1 API stuff, that's all sits on top of LibFabric as well. And it was really designed from the ground up to be scalable and high performance. You know, from the start, stuff like address resolution, right? If you're going to scale to millions of endpoints, you need a way to do that efficiently. So they have these address vectors, which I'll talk about in a few minutes. And they really wanted to try to have a very optimized software path to hardware. So sort of minimal code to get from software all the way down to hardware. And then the network and hardware is exposed via these providers. And I'll talk about our provider in a few minutes as well. So here's your standard PowerPoint architecture diagram for LibFabrics. At the top, you have your middlewares, right? All the MPIs are supported, Intel MPI, Openmpi, MPitch, and Vapage now as well. Some of the one-sided paradigms, SHMEM, Sandy OpenSHMEM has a LibFabrics interface, Charm++. There's a whole group of various middlewares that are supported. LibFabric has 4 sets of services, which I'll talk about for the architecture. And then again, all of this sits on top of these providers. So there's an OPX provider, which is our OmniPath provider. Cisco has one. Amazon has one for the EFAs. There's a few others. There's actually a sockets provider as well, which makes sort of development easy on your laptop. So the control services essentially interrogate the fabric for capabilities it can provide or that the application needs. The primary interface here is FI get info. It's very similar to like a get adder info, the standard libc sort of call, if you've ever used that for like socket stuff. But you get back at capabilities structure and mode bits. And the capability bits are basically what you as an application or middleware, this is more middleware, right? So this is MPI making the request. This is what you as that middleware, what features you would like to see and to use, right? So for example, MPI wants tagged messages. SHMEM has various fence semantics, so you can say that you do need like strong fence semantics or not. Other similar sorts of capability bits are out there as well. And then the mode bits are sort of used to convey the requirements that the application or middleware must adhere to based on that given fabric. So this is typically related to hardware stuff, right? The other sort of common one is the size of the context structure. Tim actually talked about this before. There's a big structure in LibFabrics that sort of keeps software state. We happen to require more bits or more bytes than some other providers. So there's actually a special capability, or sorry, special mode bit that says we want a larger structure there. If you need buffered sends, buffered receives, similar things. And if your application knows these things ahead of time, it's possible that you can actually get better performance if you're targeting those capabilities and those mode bits that exist. The next, Cool, thanks. The joys of technology. Yeah, so LibFabric also provides communication services. These are sort of setting up the communication ahead of time. This is endpoints, for example. LibFabric provides multiple types of endpoints, connectionless unreliable, reliable connected, and then reliable unconnected. It also provides scalable endpoints, which are kind of cool. These consolidate multiple hardware resources into a single software resource, so you can track multiple rails, for example, which gives you better threading performance and reduces memory as well. You don't have to track every single piece of hardware. You can do it as a single software entity. And as I said, this utilizes address vectors, which essentially map higher level addresses, like an MPI rank, for example, to fabric-specific addresses. Think like a socket address or a lid, for example, or maybe a MAC address. And there's two different types in LibFabric. AV map, which is essentially just a 64-bit address. This is typically directly mapped to hardware. This would store like your MAC address or a lid or whatever. And then the more scalable one is the AV table, which has an index to minimize the memory footprint, but you also have a performance hit because you have to look up that index every time you do a data transfer. LibFabric also provides completion services, right? So everything is asynchronous. So LibFabric has multiple ways to do this. There's counters, which are lightweight mechanisms for data transfers. There's event queues, which are essentially just asynchronous events have occurred. You know, this is maybe setup, teardown, that sort of stuff. There's completion queues, which are actually used for data completions. And these are optimized to report successful completions, right? So these are targeted to minimize performance in sort of the bad case, right? This is definitely meant to be your good flow is optimized there. There's also poll set, so providers that require the host processor to make data progress via an application thread. LibFabric supports that as well. And then the final thing is just data transfer services, right? You actually have to move your data around. And LibFabric supports multiple communication paradigms, kind of all your standard stuff, message queues, RMA, atomics. It does have support for tag matching as well. So, LibFabric versus Verbs, right? Verbs was really not designed around HPC messaging. You know, back at the time, it was really, I mean, IBE was really more storage stuff, right? It was not necessarily well targeted for HPC communications. So it requires significant setup and memory for basic data movement, right? So if you want to do just a generic send, you have to set up multiple work requests, and you have to set up scatter gather entries. And then when you actually do the data movement, you have to loop over these work requests with multiple branches that are hard to predict. You have to loop over multiple scatter gather entries that also have multiple branches. So it's not really performant for low level HPC traffic. You know, hundreds of lines of code, most of it's not directly related to hardware. It's mostly setup and initialization of structures and such. LibFabric has much cleaner interfaces. There's no loops, and most of the branches, there's only a couple really in this sort of same code path, and they're much more predictable. So LibFabric versus UCCX. So similar to the OFA, the Open Fabrics Alliance, the Unified Communication Framework, UCF, is sort of the umbrella organization, has broad industry partner support as well. There's multiple working groups or projects. So UCX is the point-to-point one, which I'll talk about a little bit. UCC, Rich talked about yesterday, that's the collectives interfaces. OpenSnappy is the sort of DPU group there. It's primarily used on IB and Rocky. So again, UCX, Unified Communication X, is similar to LibFabric's, provides functionality needed for HPC application spaces. The TL framework, so this is sort of a UCX layer diagram. The TL framework is similar to like the providers in OFI, but they're a lot simpler to implement. They're much easier to implement. Maybe a little more philosophical opinion, but I still think these are fair. I think UCX is very efficient for constructing HPC primitives used by the upper level protocols. It's very good at making tag matching operations, for example. It's a much simpler API than LibFabric. If you've ever looked at like netmod or CH4 or BTL, MTL, and Openmpi, those internal mechanisms look really similar to UCX. Like you could go back and forth pretty easily, right? So it uses callbacks for completions instead of or for notification rather than completion queues or pull sets. I would argue LibFabric is a little more application centric, sort of a little higher level up. It still provides low level services, but I think it's targeted slightly higher up. There's more endpoint options, like I said earlier, which sort of can get you to some non-traditional HPC spaces. Early on, there was a socket provider for LibFabric. I think there's one in UCX now. I have not looked for a long time, so I'm guessing there's a socket provider or socket TL for UCX these days. And LibFabric started by being thread safe early on. I know it took some effort, but UCX is thread safe now as well, I'm fairly certain. So, but at the end of the day, they both provide very similar performance benefits, right? They're just slightly philosophical differences, but really they both do the same thing. There's only so many ways you can move data around, right? So, okay, so OmniPath and OpenFabrics. So the OmniPath hardware originally utilized this performance scale messaging PSM. This was sort of a monolithic, very large, almost the same job as LibFabric, directly tied into MPI, Nickel as well. We actually implemented a little shim wrapper to make PSM2 a provider in LibFabric, because normally it would be this big monolithic thing and wouldn't be part of a provider. All of our new efforts around OPX, OmniPath Express, this was originally based on a BlueJean Q provider, which was kind of nice for us because this means very minimal instruction count, highly memory efficient. BlueJean Q had very minimal memory per core, very large number of cores total, right? The big BlueJean Q machine had 6 million endpoints, and this was many years ago. It's a completely standalone provider. There's no wrapper shims like there are for PSM2 there. And it utilizes the same existing Linux HFI1 driver that PSM used. So this is completely switchable in user space, just a command line option if you want to use OPX versus PSM2 at LibFabrics. This is slightly older data. I don't know if we have newer data. We should probably get newer data at some point, Tim. But this is showing instruction count improvement over PSM2 versus OPX, right? So we're at a, roughly a third of the instructions total, and significantly fewer cache touches and manipulations as well. So this is why we see the huge benefits with OPX over PSM2. So just a few more details on our OPX provider. We're entirely open source. We're upstream first. Optimal protocol and hardware paths are selected at runtime. We have the standard protocol suites, right? Eager, multi-packet, Eager, Rendezvous. And this is the software stack for CN5000 and beyond, which I'll talk about here in just a second. I had to throw one performance result in here. This is Vapage versus Openmpi. Basically, Vapage 3, I just grabbed it yesterday, and then OmniPath 4.1.5. This is the latest LibFabrics. So Vapage is just a little bit lower, not much, but that's about 1.03 versus 1.10 microseconds. And Vapage is actually getting better at the larger message sizes, so that's good to see. It's been great working with DK and his group to get that OFI support there. So one quick slide on the future. So next year at MUG, we'll actually hopefully have results from CN5K. This is our next generation 400 gig adapter. We're going to support new topologies such as dragonflies and megaflies with up to 330,000 endpoints. All of our switches are going to be managed. We'll have OpenBMC support there with Redfish as well. I can see some interesting research projects looking at, similar to like the last speaker talking about power. We can get some of that data. You can, run some collectives and sort of see the switch, power and such. We'll have fine-grained adaptive routing. for congestion control and management. And then this is the same software stack as we have today, right? So all the efforts that we're putting into Opal 100 software today will actually carry over into the next product. So that's getting us ahead of the game there. And that is basically all I had. I just wanted to have sort of a quick overview, run through, and get us maybe slightly more on schedule. I think we're still a little off, but try to keep it a little short.
Thank you. Let's give any quick questions for Brian?
I know I'm between you and lunch, so let's, and a photo, sorry, the photo first.
Anything on the online? Okay. So if not, let's thank. So let's work out on these photos. There is logistics. So might be we'll first take the Zoom people. So we told them to turn on their videos. Are you trying to share here and take a photo, or from there?
I can take the photo here.
Okay. So let's okay. But can you share that? Let's see. And then I think we have our photographer here. Okay, so we have to follow him and see where he wants to take the photo. Put it in the group. Okay. So I think I see a lot of familiar faces there. So let's take a photo capture first. Okay, so you got. So Adam, you have that last year's mug. We have a new mug. You can come this year. We'll we'll send it to you. Okay. It's done. Okay. So thanks a lot again. We'll take another photo and then we'll combine. Okay. So we'll meet again at 1:30. We'll take a local photo here, lunch, and then join back at 1:30. Thank you. So let's follow. Did we get the?
Yeah, we got it.
No, the photographer.
Are we still meeting at 1:30?
Yeah. We'll be back to schedule. Let's just.